Hello, welcome to our project. My name is Juan.
My name is Ana.
My name is Lisette.
My name is Lucero.
My name is Cassandra.
And we're group 3, and we're going to talk about some concepts and mainly a problem about piecewise functions. Hi, the first question is, what is a rational function? A rational function is the one that is represented in this equation. It is f of x equals px over qx, where px and qx are polynomials. The value of px can be any number except a number that makes q of x 0.
How to obtain an oblique or slant asymptote. The way that this happens is when the value or the degree in the highest or the denominator of the polynomial is higher than the denominator. In this case, the way that you can take it or that you can obtain it is by dividing this degree, this full-on equation in the numerator, by this one in the denominator. You have to fully divide it either by long division or by asymptotic division.
Well, I investigated and I'm going to show you two applications that you can use with rational functions. The first one is speed of a cyclist on a road on a certain time. So in 1 hour in half an hour he makes, I don't know, 20 kilometers. In 1 hour he's going to make 40. And the patient's attended in a hospital, let's say, in a certain time, like in 1 hour lapse or 2 hour lapse.
What's a piecewise function? A piecewise function is a function that is determined by using the different rules for different domain intervals. These are the parts of a piecewise function. First, the name of a function, in this case f of x, the braces, the rules that are part of the function, and the restrictions.
An absolute value function is a function that contains an expression with an absolute value. This absolute value goes from 0, is the distance from 0 to the point where it is. This is an example of an absolute value function. As you can see, it does not go to minus. It goes from minus infinity to infinity. This is because when you are substituting x with any value, in this type of function, because it is only x in absolute value, it will always be positive.
So piecewise functions can be applied to calculate the value of something when it has restrictions or variables that affect its constancy. For example, you pay 200 pesos for going to skate, and you pay 10 more pesos for every minute you stay there after your schedule. In this case, it's 1 hour. And another example can be that a motorized car is programmed to drive in a speed of 20 kilometers per hour and to accelerate to 25 kilometers per hour after it has passed 3 minutes.
We have piecewise function right here, meaning we have three types of function, different, linear, quadratic, and absolute value. And in the first one, we can also say that is x plus 3, because at the end of the day, it doesn't really affect the value. Meaning our slope is equal to 1, and the y-intercepts where it will start would be 3, saying it would be right here. In this case, since it's positive, it would go either up to the right or down to the left, meaning it will go from here to here. In this case, it depends because we have a little restriction, meaning that x have to be minus to minus 3. So it will start here with a minus 3 not included. In the second one, we have a quadratic function with a transformation in the vertical way, meaning we will have the exact same sort of quadratic function, but starting in minus 1, saying it will go 1, 1, 2, 4, 3, 9, etc. But starting 1 minus, like it says right here. In this case, its restriction is x have to be plus included minus 3 right here, and it will have to be less than 2 not included. For the last one, since it's an absolute value, but we have a restriction, it will not really have a reflection. It would be a slope of 1, like in this one, and it would start in the y-axis, meaning we go from here to top and from here to down. But with our restriction, meaning that x would have to be plus or equal to 2, meaning it's included. In this case, our friendly set is going to come and join us to tell us the domain in the range.
Okay, so for the domain, the x is a part of a real number and it goes from minus infinity to infinity. And for range, we have y forms a part of real numbers and it goes from minus infinity to minus 3 not included union minus 1 not included to infinity.
For this piecewise function, we have two intersections with the x-axis. The first one is minus 1, 0, as you can see in the graph, and the second one is 1, 0, as you can see also in the graph. And we have only one intersection with the y-axis, as you can see in the graph, is in minus 1. Solution for all the terms we investigated, we have a piecewise function. That's why we don't have any asymptotes nor empty holes in our graph. That's because we don't have a rational function.